Okay, so I'm going to try to recreate Lewitt's poster of all the open cube possibilities. So this is a 2D poster, but it represents 3D shapes, and we'll try to figure out ways of doing that. So I'm going to start with the square grid. So this grid, okay, so let's make this a little bigger. Make it roughly 8 by 8. Okay, so I have this grid and I want to put hexagons on the inside of that start to sort of represent the cubes. So to do that, I'm going to get the area of each one of these, which also will give me the centroid, the center of that. And then I'm going to put polygons on them. Now, right now, the polygons are rotated in the wrong direction. We want the point to the top, so it kind of looks like the cube is in axon. So I'm going to rotate these planes. Actually, I have to make a plane, so it's an X and Y plane at each one of these center points. I'm going to rotate it like 30 degrees. Then I want to make these slightly smaller. Like so. So what you have is these hexagons, and I can build these crossing members to finish making the cube. So to do that, I'm going to need to make a center point of that, which I can use the area again. I want to get the outside segments, so I can explode that. Gives you those outside segments. And then I want to draw lines from these points to the middle to get the inside segments. So I don't want to do it from the explode, because the explode actually gives me 7 points. You need 6 around there and then 1 to close it. Turn on my bifocals so you can see these a little bit better. So I'm actually going to use a discontinuity. It's roughly the same thing, except that just gives me 6 points. So I can draw a line between 2 points from the center to these points. So I need to work on my data management so that those are in the same sort of organization. So let's see if we can simplify this quite a bit. Simplify this quite a bit. So that goes down to 0 through 7. With 8 of those on the inside. And this goes down to a data tree. So let's see, what can we do? Let us flatten this. And then I'm going to graph these. So that gives me a 0 through 63 and a 0 through 63 there. So that's kind of what we want. So if I turn this one off, so then I have the outside lines right there and the inside lines right there. So let's combine those. We're going to merge these two things, the segments from up there and the segments from up there. And we have what look like cubes sort of floating around an axon. Something I just noticed that we're rotating in radians. Let's change that to degrees. So roughly vertical. Okay? So we have all of these lines. We should have, oh, now look at this. We don't have the right data sets for these two things coming in. So let's see if I simplify both of these. There we go. Now we have 12 items in 64 different trees. Okay, so let's see if we can get rid of some of these lines in some of these boxes so they'll have a couple different variations of that. So I'm going to try out random reduce. We take all these lines, we're going to plug them in there, and then it'll tell you how many you want to get rid of. Well, if we just plug in one number, say we want to get rid of 5 of them. Turn off this. They're all going to be the same. So we don't want them to be all the same. We actually want them to be all different. So we could plug in different numbers. Let's make a new random number generator. And what we want to do, so if we get rid of, we can get rid of 1 and it approximates something. That 3 lines could technically still approximate a cube, but when you start to get rid of 10 of them, then you kind of lose that 3-dimensionality to it. So let's stop it from 1 to 9. So I'm going to construct a domain that at a minimal will get rid of 1 line, at a maximum we'll get rid of 9. And then we want 63 variations of that. I'm going to plug that into there. Okay, so if we make this data set the same, so it's roughly 1 number per each one of those, 1 number per each one of those. You get some variations, but then there's a lot of repeating ones, which is not what Lewitt was looking at. He was looking at all variations of different ones. Okay, so let's try a different sort of strategy for this. Instead of using this random reduce, we're gonna take these and do something else. So if you remember back to our Boolean operations, we can use those to cull out items. Let me turn these back on. So if you think of these as having 12 legs that we can possibly take off, if we say that each one has the possibility of being a 0 or getting taken away, or being a 1 and getting left in place, then we can set up a list of items that have 0s and 1s that represent each one of those. So what I'm going to do is I'm going to make a panel. So make a panel with 0 and 1. Make it multi-line data. And then I'm going to plug those in for 12 different items. And I want those to cross-reference each other. If you remember what cross-reference was, basically took each item and made variations of that. So, but I want to do that for 12 different ones. So I'm going to add enough of these. Plug them into all of them. So you get all the iterations of these. And it looks like there's a potential for over 4,000 different combinations of this. So that's a lot. Let's just pick a group of them. But first I want to put them together. I'm going to use a concatenate, which basically is just taking all these and putting the text together. So I also need 12. So that gives me all the possible variations of 12 numbers. You can see the first one is 0, 0 all the way. The next one is 1, and then all the zeros. And so that goes all the way up to all ones. And so all possible variations of that. So I'm going to put those characters together. So that we have them each individually stored in different trees. Let's simplify that so that each one has its own potential tree. And then I want to, we only have 63 possible variations of that out of our total 4,096. So I want to call out some of those. So we have 4,096 of those. I want to, in my cull pattern, if I want to take these 63 and pick 63 variations of that I'm going to plug into this cull pattern. So this cull pattern is actually using these, right? And I'm going to plug in true false values for each one of those. So I'm going to take this overall list, and then I'm going to use a tree branch. So this is going to select one of these branches, maybe 8, maybe it's going to be 500, I don't know. Let's select them at random. So what I want is of the 4,000, I want 64 variations of those. Let's give it a C value, it doesn't really matter for that. That's going to give me 63 variations of that. I'm going to plug that in here. And you see it picked 3, 30, 84, 115, all the way up. So we have 64 variations of 12 true-false values, and that becomes our cull pattern. Preview that off, and you see what we have left are all unique values of OpenCubes. Now all of them aren't connected, but they're all unique. So you could go through and sort of filter out ones that you don't want to use, or you can change out different variations of what that cube is going to be like. I think that's it.